Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to discuss the simplex method. Basically, we are going to solve a few problems related to the simplex method. In the process, we are going to try to explain the procedure, how to deal with this one. So now let's see simplex method. So from your Rao's book, so your example 3.4. So this is a maximization problem. So you have to maximize f. In the Rao's book, capital F is being used for maximization and smaller f is used for minimization. So, and also we know that maximization is just a negative conversion of your minimization problem. So just multiply the negative sign, we can have our maximization problem. So now the function that has been given, f maximization of f is x1 plus 2x2 plus x3. And the constraints given, subjected to the constraints to x1 plus x2 minus x3 is lesser than or equal to 2. The second condition is given as minus 2x1 plus x2 minus 5x3 greater than or equal to minus 6, and for x1 plus x2 plus x3 is smaller than or equal to 6. And also, we will always find this criteria given along with the inequality constraints, that is xi is greater or equal to 0. In this case, I equal to 1, 2, and 3. So one thing we have to keep in mind that whether it is a maximization problem or minimization problem, we'll always try to take the variables, these variables, that is x1, x2, x3, into the side where this will have a negative sign. Okay. So this is what we see from practice, whether it is a maximization problem or. So what does it mean is we'll try to do something like this. F minus x1 minus 2x2 minus x3 should be equal to 0. So this is what you're going to do, whether it is a maximization or minimization problem. This is first thing. Second thing is all the constraint has to be smaller than or equal to. So if there is any greater than or equal to, then we'll convert it to also smaller than. So just, it's simple, just multiply with minus 1. Ultimately, it will be converted to 2x1 minus x2 plus 5x3 smaller than or equal to 6. So the first step of solving a simplex method problem, optimization using the simplex method, is basically bringing all of them a format like this. So this is first thing. And then second must thing is that we have to take all of this into some standard form. So some standard form is given. So basically all these smaller than or equal to constraint or inequality constraint has to be converted into an equality constraint using some slack variables. So in your Rao's book, they have used additional parameter like x4, x5, x6 in 3 equations, but it seems easier for me to separate the slack variables from the actual variable is using S1, S2, S3. So that is why I'm following that, but it's up to you. Whatever you prefer, you can do that. So standard form. Standard form. So let's write the three equations first, and we can see that we have three equations. So basically, there will be three slack variables will be required. So for this one is 1 maybe, for this one is 2, for this one is 3. So let's write the equation in such a way that all of them are available in all the equations. So basically, f minus x1 minus 2x2 minus x3 minus 0s1 minus 0 into s2 minus 0 into s3. So it's up to you whether you take plus or minus, but in the book they have used plus here, so we are also taking plus here. Okay, equal to 0. Because those are 0, so whether you take plus or minus, it doesn't make much difference. So then minus 2x1 minus plus plus 2x2 2x2 x1 plus x2 minus x3. Then you will have plus s1 plus 0 s2 plus 0 s3 equal to 2. You will have the modified one. We're going to take this one. So basically 2x1 minus x2 plus 5x3 plus 0s1 plus s2 plus 0s3 equal to 6. Finally, the last one for x1 plus x2 plus x3 plus 0s1 plus 0s2 plus s3 equal to 6. Okay, so this is a standard form. Now, once we have the standard form, next thing that we should do is to form a table. Okay, so the first table that we are going to form, we may call it the initial table or initial values, or you can also call it the iteration 1. So it's up to you. So initial table or initial iteration, or in some books they also call iteration 1. So if you call it initial iteration, the next iteration will be actually iteration 1. Otherwise, it will next one will be iteration 2. So whatever suits you, you take that one. So we're writing with the initial iteration, and the format is writing the basic variable. Basic variable. Actually, it will be better to write. It will take more time. So basic variables. Shortly, we're writing basic variables. Then variables. Variables, basically all of them here. So x1, x2, x3, s1, s2, s3. Then we'll have the right-hand side values, basically these values. So we call them right-hand side values. And then we'll have a ratio, which is known as ratio of right-hand side values to the key column. Key column values. So what are those? Don't worry. Let us proceed, then we'll easily understand. So now, what are our basic variables? always our basic variables will be slack variables. We'll start with the slack variables. So S1, S2, S3, and along with our function that is F. So what we have to do is we have to write the coefficients of those equations. So okay, so the first one, basically here, this one here. So this is -1, -2, -1. Then we have 0, 0, 0. So -1, -2, -1, 0, 0, 0. So we write it here: -1, -2, -1, then 0, 0, 0. And the right hand side value is also 0. Second one, that is S1. So for S1, this is basically the coefficients we have to take. So basically 2, 1, -1, then 1, 0, 0. And the right hand side value is 2. So we can easily write one thing. So this combination will be 0, 1, 0, 0, 0, 1. So we can easily write it. And the rest of the thing, just you have to fill it up. So basically 2 minus 1, 5, and 4, 1, 1. So the table is done. Now next is what we have to do is we have to find out key column and key row. So next job is to find out key column, and key row. So the intersection of that will give us basically key value or key element. Okay, value or element. Okay, so the procedure for selecting the key column is basically in the F row, this row, find for the minimum value or most negative value. So most negative. So this column is our key column. So once we find out the key column, we have said that right-hand side value, or forget to write those two values, so basically both of them are 6. So the right-hand side value will be divided by key column. So we know the value of the key column. So the ratio will be now here, 2 by 1 is 2, then it will be 6 by -1 is -6, and 6 by 1 is 6. So the procedure for selecting the key row is find the lowest positive. So if it is negative, we will not take it. So there is no question of selecting this row. So out of these two, minimum is this one. So this is our key row. Okay, so ultimately, this is our key element. So once we have key element, next, if the value is not 1, this luckily, the value here is 1. So we don't have to make it 1. If it is not 1, then we have to divide the entire row with a value that will make this particular element as 1. So in our case, it is already 0, so we don't have to change it much. So whatever it is, we just can follow that one. So this is one thing, and basically making, keep note, making key element 1. Okay, so whatever you have to do by dividing the certain values, the entire row, so you have to make the key element 0. So next thing is that we have to, now our basic variable was S1, S2, S3, as well as F. So we cannot do anything about the F. What we have to do is, whatever the key column we have, from that one, we will have a value, this one. Okay. And also in the key row, we have this value. So whenever you find out the key column and key row, and you have the key element, what we have to, for the next iteration, iteration 1 in this particular case, the procedure is the value of the basic variable, that is S1, which is related to your key row, will be replaced by the key column value, that is X2. So basically, S1 will be replaced by X2. Let's try to form this one, then it will be more clear. What do you mean by that? So if we don't want to write it again, we can just extend this one and just extend this table. If it's better actually to write, because we have to link it, and it's difficult with separate values. So that is why I'm trying to write it again here. So basically here, so X1, X2, X3, S1, S2, S3. Okay, then right hand side values, then we have ratio. So in the handout, I'll try to give you, and I have actually used a separate table, but in this particular case, what you have to, we're just, while we're trying to explain, just to link, because our space is limited. So that is why I'm just writing in short. So now what will be our basic variable? Basic variable will be S1 will be replaced by X2. The terminology they use in general is basically S1 leaves, X2 enters. Okay, so X2 will be coming here. And S2 will be remaining as it is, and S3, and finally your F. Okay, so since the basic element is already 1, we don't have to do anything. In the next problem, we'll try to explain. We'll try with one example so that you can see how the value is been actually converted into 1. So key row, you have to write first. This is the procedure. So key row is basically 2, 1, minus 1. Then you have 1, 0, 0, 2. Next thing is key row is key column is actually this one. So the other variables here, other values here will be 0. This is the procedure. And whatever you have to do to make this one 0, you have to take those operations. Okay, something like this. Let me explain. Say this is your row 1. Red color will be better. So basically, this is your row 1. This is your row 2. This is your row 3. And finally, this is your row 4. So row 2 of the second table, say row 2 prime is, row 1 prime is basically same as your row 1. So nothing you have to do. Otherwise, if there is no one was no, if it, A1 is not available here, then you have to maybe divide the row 1. So what will be your row 2 prime? Row 2 prime will be what was our previous value is basically -1, and this value is 1. So if you just add those two, R1 and R2, then this will give us 0. So our target is to do is R2 plus R1. Just add those two. And those two has to be applied in each cell here. Okay. So definitely this is 0, first one. The second one, this is 0, 2 plus 2 basically. This will be our 4. If you add those two, the second one is 0, 1 minus 1. Then 5 plus 1, so it will be a 4 as well. And then you will have 0 and 1, so basically 1 will be there. And then next one will be 1 as well. 1 and 0, then 0, 0 is 0. Then 6 plus 2 will be 8 here. Okay, so next, what you have to do for R3 prime to be 0. So for R3 prime to be 0, basically, what you have to do is R3 minus R1. So if we do that, R3 minus R1, then this is definitely 0. What about this value? R3 is 4. So 4 minus 2 will give us 2. Then what will be the next value? Next value will be R3, 1 minus 1. So that will be 2 as well. Then 0 minus, so it will be 0 minus 1, so it will be -1. Then 0 minus 0 is 0. 1 minus 0 is 1. And 6 minus 2 is basically 4. Finally, the last one, so R4 prime will be, what is R4? R4 is basically -2. Then R4 plus you have to have to add 2R1. So this is 0. Now what will be this value? 2 minus 1 into 2 into 2, that is 4. 4 minus 1 is 3. Okay. Then you have -1 plus 2 minus 2, that is actually 2. So -1 plus -2 is -3. Then you have 0 plus 2 into 1, that is 2. Then you have 0, all zeros, 0, 0, and then 4 minus basically R4 plus. So 0 plus 2. 0 plus 2 is into 2, that is 4. So now go to the, so go, which one should be our key column? So the procedure is to find out most negative. So most negative here is this one. There may be a question how long we have to carry this operation. So uh, we have to find out that all these values has to be non-negative. Non-negative. The coefficients here, it means this one, this one, this one, this one, this one, this one. All of them has to be non-negative. So whenever this is arrived, then we'll stop our iteration. So since still we have -3, so one of them is negative, so we have to keep continuing. So keep doing the iteration. So most negative is -3, most negative is -3. So this is our key column. So this is our key column. Okay. And then which one is our key row? So for the key row, we have to find out the ratio. So ratio is right-hand side values divided by key column values. Key column values. So basically, this is 2 by -1 is -2. Then 4 by 8 by 4 is 2. Yeah, then you have 4 by 2 is 2. Okay, now there is a, this one is definitely cancelled because we have to take lowest positive. So now you have a tie. So both of them are actually 2. So in this case, it's up to you. You can take any one of them. So we're taking the first one arbitrarily. You can go for any one. So this gives us the key value is 4. So key value is 4, but this is not 1. So now this is the value is not 1. This was your iteration 1. So you can also term it here iteration 1. Actually, the table name you can give iteration 1. So the next one will be iteration 2. So in the iteration 2 as well, just let us expand the table, extend it so that we can make it easy. On us, okay. Okay, so now first thing first, basic variable. So we have to find out which one will be entering and which one will be leaving. Then we have our x1, x2, x3, s1, s2, s3, right-hand side value, and the ratio. So now key column will enter the value of the key column. So basically x3 will enter and s2 will be leaving. So x3 will be entering in place of s2. So s2 will be leaving. So here we'll have x2, then you'll have x3, then s3, and finally f. Now, what should be the value of our R1, R2, and R3 double prime? Okay, so let's see. First of all, key element is not 1. So key element has to be made 1. So, and our key row is basically this one. So your R2 double prime will be R1 prime divided by 4. Okay, so this will be 1, 4 by 4 is 1, 0, 1. Then 1 by 4 is 1 by 4. Then you will have 1 by 4 again. 1 by 4, then 0. Then 8 by 4 is 2. Okay, so this is your key row. Now, once you have this element 1, the rest of the element of your key column has to be 0. So basically, we have to make this one 0, 0, and 0. And for that, whatever the operation we have to do. So as you can see here, that this value is -1 and our key value is 1. So if you just add those two, so basically R1 double prime will be R1 prime plus R2 double prime. Okay, so if you do that, so this value is becoming 1. So basically adding those two values. So 1 will be added with 2. So that will give us 3. 0 will be added with 1. So this will be 1. This is already 0. So 1 will be added with 1 by 4. Okay, so this will give us 5 by 4. And 0 will be added with 1 by 4. So it is 1 by 4. Then 0 is added with 0. And then your 4 is added with then your this 2 will be added with this 2. So basically it will be 4. Now what about our 3 double prime? Or 3 double prime will be simply what value we have? 2 we have, and our value here is 1. So we have to make R3 minus R2 double prime into R2 minus R3 prime previous value, R3 prime minus 2 into R2 double prime. So this will give us this value 0. Now R3, previous value of R3, there is 2. So 2 minus 2 into 1. So this will be 0. Then 0 minus 0. So basically this will be also 0. Then R3, which is basically minus 1. Then minus half this one, if we multiply 2. So this will be now minus 3 by 2. Minus 3 by 2. And this will be minus half. Okay, so this will be 1 and this will be 0. Okay, how it is coming? Basically, previously it was 4. Okay, and then 4 minus 2 into 2, basically 0. Similarly, the fourth one, that is R4 double prime. So it is minus 3. So what we have to do is are 4 plus 3 are 2 double prime. So 3 are 2 double prime. Okay. So the previous value is this, is 3 plus 3 plus 3 plus 3 into 1, that is 3 plus 3, that is 6. Then you have 0 both of them, so it has to be 0. Definitely this one is 0, and you will have 2 plus 3 into 2 plus 3 into point 3 into 1 by 4. Now if you just calculate, and you're going to get 11 by 4. Similarly, 3 by 4. Then you'll have 0 and 4 plus 2, 3 into 2. So basically 10. So now whether our all the values of the coefficients of x1, x2, x3, x1, x2, x3 are non-negative and not. As you can see, all of them are actually non-negative. Okay. So since the condition arrived, so our iteration is done. So iteration is to be stopped or optimum condition arrived. Condition or optimal values, actually it should be correct thing to say. So optimal values obtained. Okay, so now what is our optimal value? Optimal values. So basically, first of all, your f value, f is equal to 10. So f, which is of course f max, is equal to 10. What is the value of x2? x2 equal to 4. So x2 equal to 4, x3 equal to 2. x3 equal to 2. But there is no x1. So it means that our value of x1 is basically 0. So this is our optimal values. So in the book, they also have figured out the value of S3 is also. So they also have mentioned that S1 is 0. S2 is also 0. And S3 is basically, also you can see there is 0. Yeah. So, but this is not our concern, even though the book have used those. We are not going to mention that. We are happy with these values. So basically, the value of the function as well as for the values of h, for the values of x. You can also actually say that these are basically or x star values. So basically, you can also write x2 star, x3 star, and x1 star. Or you can also write here like f x star with maximum if you want. Okay, so this is problem number 1. We are yet to be solved 2 more problems because 2 more special cases are available in the simplex method. So inshallah, we'll try to upload 2 more videos or in the next week in the physical class, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.